Today, we are going to look at the transportation of sugars in plants, also known as the pressure flow theory. Plant cells use glucose and other sugars as a source of energy. They need it for growth, to carry out normal tasks, or just for storage for later. There are 3 stages that happen in sugar transport. The first is the sugars go from the source cell to the phloem tube. The second is translocation, and the third is the sugars go from the phloem tube to the sink cell. So the first stage is the sugars going from the source cell to the phloem tube. So first we have photosynthesis that happens in the source cell. The source cell has the sugars. They transfer those sugars to the companion cell, and the companion cell transfers them to the phloem tube. After photosynthesis has happened, we start in the source cell. A source cell is a plant cell with a high concentration of sugars and other solutes, such as the leaf cell. These sugars then get transported to the companion cell, which leads to the phloem tube. A companion cell is a specialized cell that regulates the flow of sugars and nutrients that go into the phloem tube. So as we can see here, there is the companion cell that's squashed between the phloem tube and the source cell. From the companion cells, these sugars are directly transported to the Sev cells, which are the cells that make up the phloem tube. So we can see here the companion cell, and then they're transported over to the phloem tube. As sugars go from the companion cell to the phloem tube, the sugar concentration tends to increase. To get these sugars moving, the water comes in from the xylem cells by a process called osmosis. So we're going to talk about osmosis a bit. So we have our xylem tube that has water, and when the concentration builds up in the phloem tube, water comes in. This increases the pressure in the phloem near the source cell, so the sugars start moving towards their destination. Next is our second stage in sugar transport, which is translocation. Translocation is the transport of sugars through the distance of the phloem. So in our rectangle here, that's the phloem, and that's where this stage will happen. And the phloem tube is not hollow, it is made up of living cells that form a tube. So here we have our phloem cells in a tube shape, and the sugar needs to move through these living cells. And this all happens very quickly. The pressure flow theory is a theory, so the amount of time that it takes to travel through the phloem varies, and we're not too sure. It all depends on the pressure of water that drives the sugar to its destination, which is the sink cell. Now we move on to our last stage, which is the sugar from the phloem to the sink cells. So after translocation, we have our sugars at the bottom of the phloem. Those go into the companion cell of the sink cell, and then finally they go to the sink cell. So we have our sugars, our companion cell, and the sink cell in our diagram here. So when the sugars reach the companion cell, the sink cell, they flow in because there's a low concentration of the sugars by the sink cell, so they easily just pass through. So we put our xylem back into the diagram here. So when the sugars go into the companion cell, the water goes back into the xylem because it's not needed to put pressure on them anymore. So again, from the companion cell, the sugars go into the sink cell. A sink cell is a cell with a low concentration of sugars that converts them into starch for energy or for storage. So that is it. We'll do a little recap. So we have our xylem, phloem, 2 companion cells, our source cell and sink cell. So the sugars start from the source cell, go to the companion cell, then to the phloem. High concentration builds up. Water comes in, pushes, translocation from the companion cell to the sink cell, then the water leaves to go back into the xylem. So to finish off, now that the sink cells have their sugar, they can use it as energy, they can grow, and they can also store it for winter seasons.
created using Powtoon.